Welcome back to the Monday Morning Haskell video blog. Perhaps you saw our episode last week on the function application operator. This week we're talking about another sort of esoteric topic, and that is the function monad. And I wanted to do a video on monads because this week I'm excited to announce that we are releasing our Making Sense of Monads course. This is the newest course from mondaymorninghaskell.com that will teach you all the fundamentals of this really crucial topic that it's important to learn about monads if you really want to use Haskell at a high level. So the link for that course is in the description here. If you subscribe to our mailing list, there's another link for that as well in the description. You'll get a special discount on this course and on all of the courses on our Monday Morning Haskell page. So make sure you subscribe for our mailing list as well. Now, to get into the topic for this video, let's start by thinking about just monads in general. I have a function here written in the IO monad, and there's nothing particularly extraordinary about this, but it's interesting for us to look at the structure of do syntax and the structure of a monadic function, because this is going to help us understand how functions in and of themselves can be a monad. So let's look at the at each line of this function and assign it a type signature. So this first line we use putString line, so that's just IO unit. Now the second line we have two pieces. We have the part on the right, get line. This is an IO function, so IO is our monad, and it returns a string. So we can go to the left side of the line, and you can say that name is now a string because we have an IO string expression over here. So on the left side, it's just a string. Same thing on our next line, except with a handle. Open file will give us a handle as a result of the IO action. So assign that type right there. And then our final two lines, these are also just IO unit. They don't have, we don't get anything out of them, so they're just the unit type. So this is the general structure of a monadic function. We can, we can take this IO example and then generalize it a bit further. So let's think about what does it mean where we have sort of the monadic expression on the right side and then the unwrapped expression on the left side. Let's just write a really general version of this. So let's suppose we have some function, some monad, we don't care what it is, and we'll say, okay, this just returns an int in whatever monad this happens to be. We'll call this our monad function, and we'll use do syntax. So let's say we have x1, expression 1, and this will be something in our monad. Let's just say this is a monadic expression. It returns an int. It'll get us result 1, and we can do the same thing. Have another line, second expression. Again, these are just generic. We're not really going to find them just yet. And then at the end of this, we are going to use a return statement. So we'll say, we'll add these together. We'll add, result 1 and result 2 together. And so our final result, this is going to be in our monads, going to return an int, the sum of our previous ints. And again, we can use, our scoped type variables and unwrap these values. So we have these unwrapped ints over here because on the right side of the get operator, we have, a monadic expression containing that int. Now, here's where the fun begins, is that we can consider that there is a monad instance for a function that takes a particular parameter. So I think if you were to actually look it up in the documentation, it looks something like this. This is monad, and we have sort of this function argument operator with R. So arrow R is a monad, and we're not actually going to define that or anything. It's already defined, but what this means essentially is that instead of just using a generic n here, let's just say we could take an R, and it's a function now that it takes R. how does this, using, function r, how does this fit into the type signatures we already have in this monadic expression? Well, what it means is that instead of an m here, again, it's exp1 would have to be a function that takes some value r and returns an int. Same with expression 2. And we don't change anything on the left side. These are still integer values because we've unwrapped them from our monad. And then our resulting expression, same thing. Takes some r value, produces an int. Now, let's go ahead, let's make this a little more concrete. Let's imagine that r is just another int. So we're now defining our monadic function. It takes one int, it produces another int. This is how we have the function monad. We're no longer in a generic monad m, but rather we seem to have just a normal function from int to int, but we're still going to write it using do syntax. And I just find this kind of cool, that we can fill in r, so we have int to int in all three of these cases. And now, so what are some things that we can fill in for, expression 1? Well, we just need some kind of function that takes an integer and produces another integer. So let's say +5. That's one example of a function. And then we can do the same thing with +11 on this second line. This is another function. And now we should be at the point where our code's actually going to compile. We have a valid function that just takes a single integer as its input. It produces another integer, except we've written it in do syntax using this kind of idea of the function monad. So if you were just say, monad func 5, our result is 26 because we have our input is 5. We add 5 on the first line. We add 11 to it, so we have 10 and 16. And then on our final line, we just add those two different results. If we want to make this a little more interesting, we might multiply them. We can also do that, different function. So we get 160, and if we do that with 10, we get 315. So this is a kind of neat example, but we might ask ourselves, what exactly is going on with return here? Because we kind of feel like we're returning a single value, like a single integer. But this return has to lift it into the monad itself. It has to make it part of this function monad. So the result of making this return, it has to be a function from an int to another int. How does it do this? And the answer is using const. Const, of course, is a function that basically takes two inputs and it discards the second input. Yes, the second one. And so when we take const and then an expression, this is a function. It takes another integer, it ignores that integer and just returns its result. So we'll actually find now that we're going to get exactly the same outcome, substituting const for return there. Now, what's also cool though, we can still use this implicit input to our function on the last line itself. So if we do, let's just make this a little more clear. So let's just say we have result 1 times result 2, but then we have plus over here without using anything else. This is properly a function that takes an int and returns another int. This should compile as well, and so it'll incorporate our input into the final result. So we have what we had before. Monad func with 5 produced 160, now produces 165 because we're adding the input once again, and the input is 5 in this case. Same thing with 10, we're going to get 325 instead of 315. And as with other monadic functions, we can write a second monadic function, also in this same monad. Now we're going to give it a different final return value. We're going to say this returns a string, but the monad is the same. We're still taking an integer as our input. So we have integer input, so these are the same monad. And as a result, when we do this with do syntax, we can call our previous func. We can say monad func. Because remember, this is just type int to int. And so we're going to produce some result. That's going to be an int as a result of that. but we can also use other functions. So for instance, we can use show. Remember that show, we can use it as a function that takes an int and produces a string. So we'll get, the show input, that's what we'll call that. And then we'll go ahead and, as our return value, we'll say const, and we'll do, show of our first result, put a space in there, and then add our, show input, our second result. And I'm going to just go ahead and use type signatures just for a little more clarity. So let's call, monad func2 on 5. Get 165, and then plus 5, because that, we called show on the input 5, and we have the same thing with 10. So yeah, we can call our previous monadic function from our new function. So it's just kind of cool to see how we can do this. Now there's one more thing I want to note about the function monad here. This might sound familiar. It's like we have a monadic context where we just have this single input. And you might think that this sounds like the reader monad. And that's, in fact, correct. If we were to just go ahead and import control.monad.reader, it's actually true that there is instance monad reader. So R remembers our input type, and that sort of parameterizes monad reader. And so if we take this sort of function R monad, there's a monad reader instance here. So we could, if we wanted to, just use reader functions within this function monad function. I'm saying the word function a lot, but it's kind of interesting. So we can use local. If you happen to know, local is a reader monad function, but we can just say local 2 times. So this takes the original monad function and it just calls that in the monadic context, except that imagine that the input was doubled. And so that'll give us another result, and we'll see that this compiles, and we can actually run some values. So now we're getting, I'm going to stem off at 2. So we'll say that this is different. It's now running our original monad function with twice the original inputs. We get 325 and 5 rather than 165 and 5 that we were getting before. And if we do 10, same thing, you get a different result. So yeah, this is, the function monad isn't necessarily the first thing you're going to want to reach for, but it's a cool little trick to know, and it might help you out in certain cases. So I'll start wrapping this video up. Once again, I want to mention our Making Sense of Monads course. If you really don't feel like you have a solid grasp on monads, you want to learn more, I highly recommend you take this course. It's not too long, and if you go in the description and you subscribe to the Monday Morning Haskell mailing list, you'll get a special discount code that'll get you, get you 20% off on the monads course, and as well you'll get discounts on our other Monday Morning Haskell courses as well. So we'll see you next week, where we will have another video for you.